In the last lectures, I explained how to draw ILD for shear force and bending moment when there is a single load and 2-point loads. Now we'll see if there are a series of loads, how to find maximum shear force, maximum bending moment and absolute maximum bending moment. Again, under maximum bending moment, there are two types at a given section and under the given load. So first we'll see how to find maximum shear force when there are a series of loads. So as usual method, this already I explained, means first you have to draw ILD for shear force and then multiply that load with the corresponding ordinate values, so that gives the maximum shear force. Now here there are series of loads, so which load you have to place at the section? So for that you have to select which load you have to place at the section. See, in the last problem what we did, it was a single load. Directly we used that load at the section and we found what is maximum shear force. And in the 2-point load, what happened, we placed one load at the section and found the maximum shear force, and second case placed other load at the section and found shear force and compared which is the maximum that we have taken. But in this case there are four loads are there, series of loads are there. So what we can do, there is one formula to find which load you have to place at the section. That means you have to use this formula, summation of WA divided by L minus W1. What is the summation of W? It is the algebraic sum of all the loads, means W1 plus W2 plus W3 plus W4, and A is this corresponding distances. So that is, suppose this is A, this is B, this is C, like that. And W1, which load you are considering, that is the W1. Okay. Now we'll see one. We'll solve one problem. A train of wheel loads shown in figure moves over a girder of 6-meter span from left to right with 10 kilonewton load leading. Find the maximum shear force at a section 2 meter from the left end support. This loading diagram is given. Okay, there are four loads, each separated by these distances, and they have mentioned 10 kilonewton load is leading. See, this moves, this wheel loads moves from left to right. So this is the first load, leading load. So this is W1, this is W2, this is W3, this is W4. So as I said, you have to use now formula. So first you have to consider this load. This is the leading load. So when you till what time you have to consider this load? See, there is one simple rule is there, like you have to do the process till the sign of change in shear at the section from positive to negative. Suppose if you substitute some loads in this equation, you get some load. If it is positive load, you cannot take that load as your load to place at the section. You have to go to the next load. So there also, if you get positive load, you cannot take that also. So till that you have to get the change in shear, means you have to get negative shear force. Okay, so we'll see this problem. This loading diagram is given. I written here, W1 is 10 kilonewton, W2 50, W3 75 and W4 is 100. So now let us take that first trial. Let us consider first load, that is 10 kilonewton, and substitute in this equation. What is that? Summation of W. Add all these loads, 100 plus 75 plus 50 plus 10. So it is equal to 235. Then A. Now you are considering this 10 kilonewton. So this is your A. Okay. This is B. This is C. Like that. Or second trial, if you consider this is A. For third trial, if you consider this is A, like that. So now substitute in this equation. 235, A is 1.2 divided by length, span is 6 meter, 6 meter span minus W1, that is the load you considered, that is 10 kilonewton. So you are getting 37. So it is not possible. You are getting the positive value. So go to the next load, that is W2, 50 kilonewton. So substitute in this equation. So I have taken this as B because you consider this, you have to consider now this distance. Okay, so substitute in this, you get 8.75, again positive value. It is also not possible. Go to the third load, that is W3 is equal to 75 kilonewton. So substitute in this equation. Now C means this is, I have to consider this load. So this is your C. Okay, so if you get substitute that equation, you get minus 35.83. So there is a change in the shear sign. So first two values were positive, so now it becomes negative. So now this is possible. So you can consider this as the load you have to place at the section, because there is a change in shear sign, means positive to negative. So now place, we can conclude that you have to place 75 kilonewton load at the section to get the maximum shear force. So what you have to draw? You have to draw simply supported beam AB of span 6 meter. It is given 6 meter. So draw that and then place this loading system on the beam. Okay, same you have to place this loading system, you have to place on the beam. So distance same, 1 meter, 1.5 meter and 1.2 meter separated by. But at the section, this is section, it is given section is at a section maximum shear force at a section 2 meter from the left end support. So section is lying at a distance of 2 meter from A. So place that section, and here so total is 6 meter. So 6 minus 2, this distance is 4. Then you have to place 75 kilonewton load here. So what happens? 75 is the third load. So this load comes this side. So right to the section, and this is one load that is left to this load 100 kilonewton. So 75 is here. So this is 100. These two are comes here. Now as usual method, you have to find shear ordinate values at different locations. So let us consider this is A, this is B, this is C, X and D and E. Now first consider usual method, left portion, that is AX, means unit load is now in between A and X. Okay, so when the unit load is in between A and X, what is shear force at X? That is, I consider this side where there is no unit load, that is minus RB. So don't consider this, this is last. You have to just multiply this load with the ordinate value. So this will not come while calculating the shear force. So that is, first you have to imagine only one unit load that is moving from left to right, A to B. Okay, so now shear force at X is minus RB. So what is RB? RB is minus, RB is Y by L. So shear force at X is minus Y by L. Now find at different points. First point at A, Y is equal to 0. So VA is equal to 0. Next point at C, Y is equal to 2. Y is equal to 1. Sorry, Y is equal to 1. So VC is equal to, if you substitute, you will get minus 0.17. Next at X, Y is equal to 2, you get this. Next, go to the next portion, right portion, means you have to assume unit load is in between now X and B. So what is shear force at X? Consider this side, AX. Okay, so what is that? Shear force at X is RA, left side upward plus, so RA is L minus Y divided by L. Next, consider at different points. So first point is at X. So what is Y? Y is equal to 2. So you get, if you substitute in this equation, you get 0.67. Like that, find at D, the distance is 2 plus 1.5, 3.5. You get this. Next at E, again 3.2 plus 1.5, 3.5 plus 1.2, that is 4.7. If you substitute in this, you get this value 0.22. Next at B, what is Y? Y is equal to full distance, that is equal to 6. So 6 minus 6 divided by 6 equal to 0. So over now transfer these points to the diagram. So first portion AX, that is this portion, so minus 0.17, so below the line is minus, then minus 0.33, that is this, and then go to the next portion, right portion XB, so at X it is 0.67, and at D it is 0.42, and at A 0.22, and at B 0. So now ILD for shear force is done. What you have to do now, next you have to find what is maximum shear force at a section 2 meter from the left end support. So what you have to do, you have to multiply this load with the corresponding ordinate. So first we'll consider maximum positive shear force. What is that? Everything is same here, only this positive shear force you have to consider this positive value. Okay, so that is 100 into minus 0.17 plus 75 into plus 0.67 plus 50 into 0.42 plus 10 into a 0.22, that is positive shear force. Next consider negative shear force, that is 100 into minus 0.17 plus 75 into minus 0.33, because now it is negative shear force, you have to consider negative value at the section. Next plus 50 into 0.42 plus 10 into 0.22. So you get this answer. So only you have to take care of that. At the section there are two values. For the positive shear force, take positive value, all other things are same, and for negative shear force, take the negative value, other things are common. So you get what is positive shear force and negative shear force. Okay, thank you.